is stock price prediction. So I have imported all the necessary libraries. Basically the stock price prediction that I am going to do it with the LSTM model. Okay, even we can try it with ARIMA model also. So I'll just give a small demo that how we need to proceed with the ARIMA model, and a complete code that I'm going to do it with the LSTM itself. So let's read the data set, okay, in which it contains all open, high, low, every column. So basically for creating this model, I'm going to take with the closed column, that is by the univariate thing. Even you can try it with some other feature also, like open, high, it's up to us. Okay. We are checking the null values, whether it contains the null values or not. Unfortunately there is not any null values. Let's check the data type of it, in which, since it contains the date column but still it's stored in the data type as object, so we need to change it as a date time. So for that purpose I have used this. Okay. So basically for doing this ARIMA model, we need to check the two things. One, it should be stationary, and if it's stationary, then automatically the p-value will be less than 0.05. okay, then we need to reject the null hypothesis. So it's nothing but if like if and only if condition. If the p-value is less than 0.05, then it's nothing but we need to reject the null hypothesis. Like the same thing, if this condition is true, then the time series, that the column that we have took, it's a stationary one. Okay. So for doing for knowing that whether our data that we are taking, like whether the column we are taking, like over here we are taking as closed, right? So whether it is a stationary or not, for checking that we can use this p-value. Okay, if it is less than 0.05, then we need to reject the null hypothesis. So it's nothing but the data, the time series that we are taking, it's a stationary ones. So for doing this ARIMA model, first we need to do it a model as a stationary. Okay, definitely most of 99% it will be in the non-stationary only. So we need to change it as stationary. Okay, I'll just give a small demo how we need to proceed with it. Okay, in which I have plotted. It's nothing but we can see that it's not stationary. I have took only one column as closed. Okay, so if time series is done by ARIMA model, then need to check stationary, as here p-value is less than 0.05. okay, where the p-value is over here I have mentioned it's 0.4. so p-value should be 0.05, so we need to reject the null hypothesis. Okay, over here I have, it's nothing but I have just plotted in with the rolling mean and rolling standard deviation. Okay, so what's the rolling mean? This is my rolling mean, and the green part is standard deviation. So based on that I have plotted. So if it's not stationary, in which what we need to do, like for example I'll explain with the column only. Okay, so for every data they have checked whether it is stationary or not. So if it's not stationary, then what it will take, it will take the two elements and it will subtract it, and based on that it will check whether it's a stationary or not. So after that it will plot, then the p-value will reduce like over here 0.4. now next time I may get a 0.2, 0.1, then 0.01, it just goes on. So till the 0.05, okay, we need to do it, and then after we need to start with the ARIMA model. So over here the task is based on the LSTM model itself, so I haven't proceed with it. Even you can try it with the ARIMA model also. So let's start with the LSTM. So before starting with the LSTM, it's so sensitive, so we need to scale the data. So I have used this library from scalar preprocessing import min-max scaler. So I have given the range as 0, 1. Okay, now it's basically it's a 1D data, right? So we need to shape it. So this shaping, reshaping, it's most important, this LSTM. So I have given as a reshape minus 1, 1. So without this, if you will run this code, then definitely it will be giving an error. So for definitely you need to reshape it. We can check the dimension over here, in which we are checking the shape. Okay, so as previously we can know that in the regression or classification one, okay, we used to take the feature, plain test split, all the machine learning thing we used to do. But in LSTM1, we are taking only one column. So based on that only, we need to create all the training data, testing data, X test, Y test, etc. things. So what I have done, it's nothing but a hyperparameter tuning only. So from the one column itself, we are making a training and testing. So splitting is done with the 70-30 ratio. So what I have done, from the total DF, so total DF over here is 2035 rows we have, in which I'm taking only 70% of the data as a training one, and rest 30 has my testing one. So it's nothing but a slide code in which length of DF, that is nothing but 2035 minus 70% of data, whatever will be coming as a thing, it will be subtracted and be taken as testing data. So it's nothing but 0 to train. It's nothing but range I'm giving from the first data to the training size is nothing but my training data, and my training size to complete 2035, it's nothing but my testing data. So even we can know that what will be my training and what will be my testing. So training size, it's nothing but 1424, and testing is nothing but 611. And over here I have just stored it in the list only. So basically over here this time step is most important one, so I'll just explain this time step. So I have given this one, but just a demo one. I'm going to change it while creating the model. So for example, this is my training data set. Okay, so in which if my time step is equal to 3, okay, then what it will be taking, first, second, 3. Okay, this is nothing but my feature, and this is nothing but my label. Like for example, in the machine learning model also we used to do in the same type, like 1 2 3, it used to train it, and based on that it will be tested. Same thing. So this is nothing but my x1, y, x2, x3, nothing but my feature, and this is my training, and this is my y train. So this is nothing but a sequential model. So for first one, for the first row, I am taking this 1 2 3 as my feature, that is nothing but my x train, and this is my y train. So second thing I'm going to do is this one, that my first row, second row, first feature, second feature, third feature. This is nothing but my x train, and this is nothing but my y train. So this is how I'm creating the model. So as I have said that this is, I have taken as a training. So this one I'm going to take it as test. The same thing I am predicting. Okay, first one, second, third. As why I am taking only 3 step, as I have mentioned, I am going to taking this step as 3. But for example, I'm giving as 3, but actually in model I'm going to get the time step as 100. So more the time step, it will be giving a better model. It's nothing but a hyperparameter tuning. Okay, we can check with any time step also. So over here for y train and y test, first, second, 3, this is my y train of my first row, and this is my y test. Second thing is this one will be my y train, and this is my y test, and this procedure goes on. Okay, so this is nothing but I have done over here, in which I have created my x train, y train, x test, y test with the help of this. So as I have explained, the first 3 features I have taken as x train, this is my y train, and next this is my x train, and this is my y train. The same thing for the x test and y test. So I have just done it. Okay, as I have said that the shaping is most important. Now as this is the 2D data, right? So I'm converting into 3D, so I have just add one over here. Okay, now before starting with the LSTM model, okay, building the LSTM model, let's know about the sequential and dense one. So over here, the sequential is nothing but the process of finding a sequence of values from a set of input values. Okay, so in time series, it's nothing but, for example, 2 comma 4 comma 6 comma 8, then automatically we know that it will be 10 because it's a multiple of 2 and it's an even number, it's just moving on. So it's nothing but the time series is nothing but it's a type of a sequential one. So for that purpose we are using this one. And dense is nothing but is a layer in is used to in the final stage of the neural network. Okay, so all the import have done over here. Basically I have done with the loss of mean square error, and optimizer as Adam. Okay, so it's nothing but taking the optimizer as Adam is nothing but faster than other optimizer algorithm, and it's nothing but a gradient descent that we used to do in the machine learning. So I have created model summary. Okay, now I'm passing my X train, Y train. um, Basically, while doing the machine learning model, we used to give the cross validation random C to improve the accuracy, etc. So same thing we have done with the help of this one, X train, Y train, X test, Y test. That how we have splitted it, like first 100 data as a X train, and the 101. Okay, that will be taken as X test, and next from second till 101 we are going to take it as X train, and my 102 will be my X test. So this is how we have done it. Okay, if you will check for running this code, it around take around 10 minutes. Okay, more than that only, so don't be panic with it. And the loss that we are getting, it will be reducing at the end. So if they're reducing, then the loss is going on good way. Like for example, over here it's going on an e raised to minus, it's nothing but 0.00 something, so it's good. And the let's check the TF version, that what we are having, it should be greater than 2 for running this model. Okay, like previously we have done the scaling data, right? Min max scalar we have given as range 0 to 1. So for same thing, we need to do the inverse transform before start doing with the finding the mean squared error, any error. Okay, so if we check with it, then it's almost same, like it's not much different. It's 163 and 107 between the training and testing one. Okay, so I have just plot over here, in which the green part, it's nothing but my testing data that I am showing over here. So the length of the test data is nothing but 601, 611, right? So basically a model that we are building, we need to predict the next 30 days, right? So what we are doing, for example, if we are finding the 1 till 100, okay, what will be my 101? So for that, my 1 till 100, whatever the values having, I need to give it as input, and then only this 101 will be predicted. So for that purpose, I'm giving as X input as, like for example, test data is 601, so 601 minus 100, so that will be 511. So that will be my training data, like 1 till 100 it will train, and it will predict the 101. So it's nothing but that. Your end step is 100. Okay, a number of days, that how many days we are going to predict, it's for 30 days, so I have given as 30. Okay, this reshaping is the most important one in this LSTM model. Reshaping, scaling the data, it's the must. So over here I have nothing but the same thing as I previously said. First, like for example, I will be giving the input as 1 till 100, and the 101 it will predict. The same like over here I have mentioned as X input np dot array 1 till n, means n elements. So for example, if I am taking 1 till 100 and 101 it's predicting, and second time I will be taking as 2 to 101. Okay, it's nothing but it's reducing the one number. So for that purpose I have used this line, in which we will be getting a output for 30 days. So this is nothing but it's how it will be finding. Thank you.